Okay, so for the past few years, we've all been getting really good at one new skill, how to talk to AI. We call it prompting. But here's the thing, just talking to an AI, that's quickly becoming the least interesting part of the whole deal. The real action, the real frontier, is shifting away from writing prompts and towards designing entire systems. Today, we're going to dig into why the future of AI isn't about the prompt, it's all about the architecture. So to really get why this huge shift is happening, we've got to start with this massive, kind of counterintuitive problem that even the most powerful AIs are hitting a wall with. I like to call it the Great Memory Trap. I'm sure you've run into this, right? You're deep into a complex task with an AI. You're feeding it documents, data, instructions, and it is just crushing it. It's performing brilliantly, and then suddenly it seems to completely forget a key detail you gave it like 5 minutes ago. So what gives? Why do these unbelievably powerful tools seem to have such a bad case of short-term memory loss?
Okay, look at this number, 80%. This is pretty wild. Research is showing that once an AI's context window, and that's basically its short-term memory, gets about 80% full, its ability to actually reason just tanks. It gets lost in what people are calling context fog. It just can't tell what's important anymore, what's signal and what's noise, and all that brilliant logic, it just starts to fall apart.
And that right there brings us to what's known as the token paradox. We see these big companies announcing these massive context windows, 1 million tokens, 2 million, and we think, awesome, more memory, problem solved. But it's a total trap. Just giving the AI a bigger box to stuff information into doesn't fix the underlying problem. It just creates a bigger, foggier box. So the crucial point is, we've been trying to solve the wrong problem entirely.
To really wrap our heads around why this is happening, we need a totally new way to think about what an AI actually is. So forget the idea of some kind of thinking brain. I want you to think of it more like a flash memory processor.
An LLM is an absolutely incredible engine for logic and execution. You give it information and an instruction, and boom, it performs that task with stunning capability. But here's the catch. The second that task is done, poof, it's gone, vanished. It has zero, and I mean zero persistent memory. It's a processor, not a mind. Every single time you interact with it, it's a brand new calculation, completely from scratch. And that, right there, is the absolute heart of this whole explainer. We've been putting all our energy into crafting the perfect prompt, that one perfect instruction for the processor. But the real challenge isn't the instruction. It's about building an intelligent memory system around that processor, one that can feed it the exact right info at the exact right time without creating that horrible performance-killing context fog. Okay, so how do we actually build a system like that? Well, this is where we put down our prompter hat and pick up our architect hard hat. The solution is a really structured blueprint called the modern context frame, and it's built on 6 essential pillars. So, this is the blueprint. Let's walk through it. First up, the directive layer. Think of this as the AI's core mission. Its permanent job description, like you are a top-tier medical research assistant. Then, pillar 2, the inquiry origin. That's just the specific question you just asked it. Simple enough? Third, the functional interface. These are the tools it's allowed to use, maybe a calculator, a web search function, or a data analysis script. Fourth, the proprietary knowledge vault. This is its special private library, that secure database of information it can pull from. And finally, you've got the cognitive trail and the execution log. Together, these are like its perfectly clean, organized memory, the history of what you've talked about, and a log of what it's already done. All 6 of these pillars, together, create this perfect, custom-built package of information for the processor, every single time.
Yeah, when you use this kind of architecture, it totally flips the script on how an AI gets its information. So the old way on the left here was basically to just force feed it. You just dump a massive pile of data into the context window and hope for the best. And that's what creates the context fog. But the new way on the right, this is demand-driven retrieval. Here the AI itself intelligently decides what it needs from that knowledge vault, and it pulls only that one specific piece of info. I mean, it's the difference between trying to drink from a fire hose versus having a skilled librarian hand you the exact book you need.
Okay, so this is big. This architectural way of thinking, it doesn't just make a single AI agent better. It actually unlocks a completely new way of solving massive, really complex problems. We're moving beyond the idea of a single all-knowing AI. Right now, most of us are stuck in the old model, the monolithic agent. It's this idea that we have one big, super powerful AI, and we just throw everything at it.
We ask it to solve a supply chain crisis by analyzing shipping data, reading news reports, and drafting emails, all at the same time. And what happens? It gets totally overwhelmed by all that cognitive overhead. It's just too much. But the new model, now this is where it gets really cool. It's called the Federated Mesh. So instead of one overworked agent, you have a whole team of specialized micro-agents that all work together. For that same supply chain crisis, you'd have one agent that only looks at shipping logs, another one that does nothing but monitor weather patterns, and a third that's an expert on geopolitical news. They talk to each other, they pass clean, relevant bits of data back and forth, and they work together to solve a problem that would be way too complex for any single agent to handle on its own. This is basically the blueprint for how AI is going to tackle humanity's biggest challenges, from discovering new medicines to running our global logistics.
And look, making this future actually happen, it involves some seriously next-level techniques. We're talking about things like recursive distillation, where an agent basically summarizes its own past actions into a tiny, compressed memory, just to save space. Or ephemeral state management, which is a fancy way of saying it uses external databases as a temporary scratchpad to handle huge amounts of data. This is deep, professional-grade system design. A whole new discipline is literally being born as we speak.
So there you have it. This is the new frontier. The real power is shifting away from the people who can just talk to an AI, and it's moving towards the people who can build the sophisticated systems that these AIs live and work inside. This is a fundamental change in how we're going to unlock the true potential of this technology. We all got pretty good at prompting over the last few years, but the real question now is, are we ready to start thinking like architects?